And now we're going to go to our next speaker, Alysha Kishan, and she'll be talking about Biomaterials Applications Database for primary and secondary education.
Good afternoon. My name is Alysha Kishan, and I'm here from Dr. Cosgrove Hernandez's lab at Texas A&M University. I'm going to talk kind of about the outreach that our lab does and our work to develop a biomaterials applications database for both primary and secondary education. And so before I go into what we've actually developed, I want to go into why we do it and why it is important for us all to participate in this type of thing. And so in 2004, just to give you a broad example, across the nation we had approximately 4 million ninth grade students. And by the time this group of students actually graduated from college, only 300,000 of them actually majored in a STEM major. And so STEM consists of science, technology, engineering, and math. And this is only 7.5% of the initial ninth grade students. And so this number to me is just shocking. And this group of students are growing into an industry where approximately 60% of new jobs in the 21st century are actually going to require STEM skills. And so as evident in these numbers, there's a huge disparity between our academic and industrial scientific community and our education classrooms and our classrooms, our education system. And so this has garnered a lot of interest across the nation lately. And our government has implemented a new plan in order to give it a sense of urgency that it deserves. And so the new effort is to try and increase and sustain youth and public engagement in STEM across all students before they actually enter college. And so as a former teacher, myself, I know that a lot of teachers are required to work with state curriculum and required to work that's what they're given. However, state curriculum is severely outdated in that it doesn't actually involve any biomaterials or biomedical engineering applications in them. And so with this, the new exciting technology isn't very exposed to students to get them excited about science. And so as members of the scientific community in either academia or industry, we're uniquely positioned to be able to help bridge this kind of gap between the new current education, or the new current technology, and our education system. And so with that goal in mind, our lab, our graduate students, what we do is we go to the middle school, like an earlier group that presented today, and once a month we just go and we run a science club. And our goal here is entirely just to get them exposed to new technologies and to see how science can be applied in the real world. And so with this middle school club, what we're doing, we're only reaching approximately 30 students once a month. And so we took that and we thought, how can we reach more students, or how can we actually help a bigger population? And so we have these set of lessons, and what we want to do and what we're currently working on is developing a set of modules that can be accessible on our website, that can be available to anyone, and so to any instructor or to any other group that actually wants to help with outreach as well. And so we're working to create a database of these lessons that we have developed to make it easy for educators and instructors to actually utilize these in their classrooms. And so with these modules, there's actually 4 different parts to each of them. And so as a teacher, like I said, it is really important to help, as they said earlier, to involve teachers and to get them as prepared as possible to actually utilize these experiments. And so these 4 components are there to help make this transition easier. The first is a kind of a background description for the teacher, and this is important in order to help prepare the teacher to actually include them and include the lesson in their curriculum and kind of immerse the current technology in what they're studying in the classroom. The second component is an experimental protocol, and so this is the actual worksheet that could be given to students to conduct an experiment. And so this includes the initial hypothesis, the protocol, the conclusion, and all of the analysis that the students need to go into. And so this allows for easy implementation into an everyday classroom for someone. There's also a video demo along with each of our experiments, and so this is just a video of one of the graduate students in our lab and what they're doing. And so they're actually performing the experiment, and they're including different checks for understandings, which are just short kind of questions that the teacher can ask their classroom as they're actually performing the experiment to see if the students are following along. And so teachers are required to submit these short questions, these checks for understandings, with their lesson plan when they submit it to their school. And so this also helps prepare the teacher and to ensure that their students are actually getting what they are trying to result in. The 4th component of our module is an end of lesson assessment. And so these are a group of 20 questions that are aligned to the state curriculum objectives that are tested with each experiment. And so what these are just short questions. They're not necessarily critical thinking questions, but they're short questions that allow the teacher to be able to assess whether or not their student did master the objectives that came with the experiment. So when it enables the student or the teachers to have really easy access to be able to track their students' progress as they go through each module. And so I'm now going to go through just 2 modules that we have actually developed for middle school applications. And so the first is a hydrogel drug delivery system. And so the scenario that is presented to the students is that researchers have developed a new drug to orally treat cancer. And it's phenomenal, but they need your help to actually design the pill and determine if the drug should be delivered as 1 large pill or 2 small pills. And so with this, and so with the kind of backwards planning that we were discussing earlier, we wanted to look at the different objectives that could be taught through this lesson. And so we've kind of made our own biomaterial objectives since there isn't really one for state curriculum. And so we would like to discuss polymers, hydrogels, diffusion, drug delivery, and hydrogen bonding with this experiment. And in terms of state curriculum, so for science, TEKS are, we're from Texas, so they're the Texas Essential Knowledge Skills that public school teachers are required to utilize. So in terms of the science curriculum, this would be investigating scientific inquiry, diffusion and equilibrium, data collection, and the design process. And for math, we're looking at geometry, algebraic thinking, and measurements. And so in terms of materials and prep work, the materials are all less than $15, or a total of less than $15 for a group of 25 students, and they're all available at the grocery store or Walmart. And for instructor prep work, what they do is we're using iodine as our medicine kind of food coloring. And what they would do is actually create the gelatin gel with the iodine the night before. So it's a very short prep time that is required. To actually conduct the experiment, the students will first cut their samples into 2 different sizes. So they'll have 1 large pill and 2 small pills effectively. And they'll first begin by measuring the volume of these 2 pill sets that they have. And then they will soak the samples in vinegar for 24 hours, and you can have them writing down observations during this time. And then the following day, they measure the new volume of each gel. And so in terms of analysis, we want them to calculate the amount of medicine effectively that was in their original gels and in their final gels. And so in order to do that, we give them an initial assumption that there's 10 milligrams of medicine in every centimeter cubed of their gel. And so they calculate how much medicine they began with and how much medicine they ended with in order to see how much was actually diffused out. So then they would combine their data with 2 other classmates in order to calculate an average amount of released medicine for their system. And based on that, they would make a conclusion on their results to see if their medicine did diffuse faster from either the smaller pills or the 1 large pill. In terms of extension questions, we want our students to kind of apply this to drug delivery. And so we would want them to see which one would you rather take if you were a patient. Would you rather take the large pill or the 2 smaller ones? And when would it be better for the medicine to actually be released faster or slower? And so this is more of an application question, just to see when this would actually matter, make a difference, and how often the patients would need to take each pill, depending on the size, as well as what else do you think the size of, or why do you think the size affects how fast medicine is released? So if the teacher wants to go into surface area to volume, or how that is actually applied, the teacher can use this as a bridge into that concept. The 4th component of the module, I don't actually have the questions up here, but it is that bank of 20 questions that are aligned to the state curriculum that are explored in this experiment. So that is available for teachers to go to in order to assess whether or not their students were able to master the concepts that were tested in this experiment. The second module that I'm going to quickly go through as well is as well with hydrogels for wound dressing application, however. And the concept for this one is, or the scenario that the students are proposed with, is that a doctor is in need of a wound dressing, and he needs your help to both design the wound dressing and to figure out how the wound dressing will impact the everyday life of a patient. And so in this case, the patient wants to go to the beach the next day, and we need to see if the wound dressing will actually still function at the beach. And so for biomaterials objectives, we're going to be looking through polymers, hydrogels, hydrophobicity, hydrophilicity, viscosity, and ionic and covalent bonding. And the science and math techniques are very similar to the first one that we discussed, in that it's scientific inquiry, diffusion, equilibrium, data collection, and kind of the design process. And so this lab is actually two parts, but the materials and prep work are still very low cost, and very minimal prep work is required by the teacher. So the total cost is less than $15 for a group of 100 students. Everything is available at the grocery store and Walmart except for the actual polymer powder, which you can buy for about $7 at Steve Spangler online. And so the prep work for the teacher would be to make 3 different salt solutions to represent 3 different beaches that the patient could go to. So it's the California coast, the Dead Sea, or the amusement park beach. And so these are 3 different just salt and water solutions that they would make the night before. So the protocol for the students, the first part is to actually help with designing the wound dressing. And so what would happen is the students would receive a given amount of polymer powder and need to add water at different increments and actually discover how much water needs to be added in order to form a gel. And so once this gel is formed, they would continue to add water and see what happens to the gel. And so if the gel gets too slushy, would it still work as a good wound dressing? And so for analysis, we would want them to actually determine the average amount that was needed. Since they are using a graduated cylinder, we expect there to be kind of a variety across the middle school students that was needed to form a gel, and how much was needed for the gel to lose its properties. And actually ask them why they think a gel that had too much water, that was too slushy, why would that be a problem for a wound dressing, to get them to apply it to a broader perspective. And then for the second part of this module, it would actually be to discover if the patient could go on and go visit the beach the next day. And so they would develop they would basically just make 3 standard gels and then put them into the 3 different salt concentrations and just see what happens to the changes of each gel. And so the concentrations are such that only one, the amusement park beach, actually works, and the other ones all become slushy and lose their gel capabilities. And so with this, we want them to actually look into what the effects are for adding different concentrations of salt to their gel, and which beach would their patient be able to go visit. And so they basically realize here that there are other social implications into utilizing these as a wound dressing application. So both of these modules are available on our website, and so what we're looking to develop is just having this as a very easy to use database where people can go there and download the lesson plan, download the student protocol, and the end of lesson assessment, and view our video demo. And so with this, we hope to compile all of our middle school applications so that people, both instructors and educators and others that are participating in outreach, can go and access these. And in terms of future work, we want to make sure we continue to develop these, but also potentially include a space on the website where they can implement suggestions and just say what kind of feedback on how it went down, or actually just suggest other modules that we could include and we could further develop. And so in order to make this a collaborative website that can be used for many different applications. And with that, I would like to thank all the members of my lab that helped and that currently go and participate in these research activities or outreach activities, and our funding sources. Thank you. I can take any questions that you all may have. No, I'm not. She said if we were aware of the website, teachingengineering.com?
There's a website called teachengineering.org that has, it's a database of lesson plans like this for teachers, and it identifies by topic, by grade level, by objectives, by, they identify state standards and that kind of thing. So you may consider publishing your modules there, and, it has a specific format that's really user-friendly.
Other questions? Could you help us, for those of us that are not as well acquainted with the state curricula as you are, in these TEKS, in your case, requirements, how often would a typical teacher repeat those concepts throughout the school year in order to really nail them down?
I think, especially for the science ones, including like scientific inquiry, those are very broad TEKS, and so those are the ones that I think when we were teaching, we would use them in every single experiment that we did, because it's a skill that can only be continued to advance, and so that is something that we would continually do across the year, whereas there are some TEKs that are just definitions, like for diffusion or something, which we would do until the mastery level of our whole class would get to about 80%. That was what our target range was.
Great. Well, let's thank our speaker again.
Thank you.